The question here is problem set number 1, the last one, which is on two substitutes. I have two videos already. It seems it's not enough because I made a mistake in the algebraic version of this, so I'm going to correct. So I have already corrected and posted a new thing, and I'm going to explain how this works here. So the thing that I was missing is these two feasibility constraints. So when I did this, I actually did it diagrammatically. I didn't do it completely algebraically, but I will show you the pure algebraic way first, and then I can tell you how to use the diagrams directly know this. But in any case, the usual way that I do it is substitute this constraint back into the maximization. So we have this minus 2 times u minus 2xb, which this is equal to this plus 3xb minus 2u. So this means it's increasing function. So when it's increasing function, we want xb as large as possible. So we want xb as large as possible, which means it's bounded by 10. So when u is smaller than or equal to 20, so we use all xb and no yb. And when u is larger than or equal to 20. So when u is larger than or equal to 20, then it means even if I use up everything, so 10 of them, I still need yb. So use up xb equals to 10 and some yb that's larger than 0 to fill the rest. So I can still maximize this thing. So, and then I think that's all we need. So we have a cutoff for u. When it's smaller, I have y equal to 0, and when it's larger, we have xa equal to 0. And so how to do this directly from the diagrams? So our usual address box and our fix the second person's utility. So the slope is 2. So we had a 2xb plus yb. So the slope is 2. If you write, if you move this to the other side, then you know that the slope in front is just the slope in the xy axis. So basically it should look like this. So I fix this, and then I maximize the other person's utility. So the other person is half xa plus ya. So we are having this kind of thing. So we move it as far as possible. So here we hit this point. And at this point, this fixed utility level is 20. So when it's larger than 20 means when it's on this side. So when it's on this side, it means u bar is larger than or equal to 20. Then when I maximize, so I still do, sorry, this is the wrong color. I still do this thing, but I hit this point. So this point means xa equal to 0, which means xb equals to 10. And on the other side, when u bar is smaller or equal to 20, you see that when I maximize this, when I move it as far as possible, we get this point. And this point means yb is equal to 0. So ya is equal to 10. So that will be how I get all these points and all these points. So I either do what I did pure algebraic way or do this diagram. I think it's a lot easier. On the exam, I actually encourage you to do it purely diagrammatically. You don't need any kind of algebra, you just need to state what you are maximizing. Again, on the exam, remember to state the maximization problem. Then don't solve it algebraically. Use a diagram and directly state, or you don't actually need to write this using set notation. You can just highlight this on the diagram and then say that part. So like what I did, so highlight this and just say that this is the Pareto set. Pareto. And that's all you need to do.